One thing that comes up very frequently, and then we're asked to do quite often, is to use the information that we know about trigonometry and the various trig identities that we know, ranging from the cos squared plus sine squared equals 1 right up to the wave equations, to prove various other trig identities and relationships between them. Now, proving these can seem fairly straightforward at times, but it can also seem very complicated. However, if we follow a set routine when we're doing it and a set way to look at the questions, we actually should manage these more often than not. And that's what we're going to look at in this video. And we're going to look at that with a couple of examples. So the first one is prove that cos of bracket 90 plus x equals minus sine x. There's no specific values given for x, so it's not just a case of pick a value and do it, pick a value and do it, because you've got to prove that it works for every value of x that could exist. Now, key thing to look for in a question like this is this sort of phrase here. Prove that or show that. Now, whenever you see those phrases, what you have to do is you are not allowed to assume it works. You can't just say to yourself, oh, this works, so I'll treat it like an equation, move a few things around and solve it. It doesn't work that way. When it says prove that, your instant thing that you have to do is assume that the left-hand side and the right-hand side, you don't know that they are equal to each other and you don't know that it works. And you can't then prove it for a single value and then assume. You have to show it for them all, as I've mentioned previously. Now, whenever you get a question like this, the first thing you should always do is focus on one side, take it, work it through with the trig identities you know, and get the other one. So what I would always do with this one is say to myself, the first thing I'm going to do is start with the left-hand side. So in this case, I'm going to start with cos of 90 plus x. Now at this point, I'm not even going to imagine that this exists. I'm not even going to assume that I know it or assume that that's what I'm thinking about. I'm going to play about with this, work it through identities, and this is where I'm going to get to. So cos of 90 plus x, well, that's written in the form of cos of a plus b. So I can use that expansion in order to be able to work with it. So cos of 90 plus x is the same as our cos of a plus b one. So in this case, I'd get cos of 90 cos x minus sine of 90 sine x. Now the x's we can't do a value for, but we know what cos 90, we know what sine 90 are. So that means that we can work with those. Cos 90, that is 0. So that means I've got 0 times cos x, which means that whole term there just vanishes. It's 0 there. Sine 90, now if you think about the way the sine graph works, sine 90, that equals 1. So what I've then essentially got is 0 take away 1 times sine x, which we can simplify to give us negative sine x. And at this point, I can then say that that equals the right-hand side. So therefore, cos of 90 plus x equals negative sine x. Now that I've shown it, I can assume it. Now that I've shown it, I'm able to say exclusively for all values of x, this works. Okay, this holds. When we're answering a question like this is the approach we have to take to it. We have to take one side, so we take the left-hand side, we work it through using our trig identities and the various properties we know, and we ultimately look to get this right-hand side. We cannot in any way, shape or form assume that it holds and then work it through. Here's another example. So show that sine of a plus b over cos a cos b equals tan a plus tan b. So a slightly more complex one. Again, it's got this phrase here at the start. So instead of prove that, it's a show that. But they mean the exact same thing. So what I now want to do is show that my left-hand side and my right-hand side are equal to each other, but I cannot assume at the start that it holds. I can't assume to begin with it holds. I have to work it through. Start with the left-hand side. So in this case, I'm going to start with this. So I'm going to start with sine of a plus b over cos a cos b. Okay, so I'm going to assume take this part, I'm going to work it through, and I'm going to get to this bit. Remember, you can't assume this works, so ignore it for the time being. Well, sine of a plus b, I'm going to use my expansion on that. I'm going to get sine A cos B plus cos A sine B. Now, that's all over cos A cos B. At this point I could think, right, I know I've got two terms in there, I want to split this off. So I'm going to split it off at the plus, and I'm going to put it into two separate fractions. I'm going to have one fraction that's sine A cos B over cos A cos B, and I'm going to add on sine B cos A over cos A cos B. So I've just split it off into two separate fractions. Now if I'm looking at these fractions, I can cancel terms out. So in this one here, I can cancel a cos B from top and bottom, and I can cancel a cos A from top and bottom in this one. So what I'm left with here is I've got sine A over cos A plus sine B over cos B. Now think back to your trig identities and functions. Sine over cos is equal to tan. Sine A and cos A, sine B and cos B. So I can say, fine, so that first term is tan A plus the second term, which is tan B. Lo and behold, that is the right hand side. So I've not assumed it's true, I've shown it's true. So now I can say, fine, so sine of A plus B over cos A cos B equals tan A plus tan B. Now I can hold it, and now I can assume it's true for anything, because I've actually physically shown that yes, it does work for every single value that exists out there. I've not just assumed it works for one or two and then said, oh, by magic, it works for everything. I have shown it works for everything. When we get a proving a trig identities question like this is the approach we have to take. Those key phrases, show that, prove that. That's what we're looking for. Once that's the case, we start with the left-hand side, ignore the right-hand side, and we work it through to get to that right-hand side. Once we've worked it through and got to that point, then we can say, this is true, this holds for everything. Otherwise, we can't do it, and that's what it wants us to show. So remember that set of steps when we're working these through. Remember how we work this through. This comes up very frequently, and it's something we have to be able to do.